In 2014, the Scratch team released ScratchJr, an incredibly simple program with the goal of helping 5 to 7-year-olds learn how to code. The ScratchJr team achieved their goal and made what I would argue is an app that achieves much more than what it set out to do. ScratchJr can function as a replacement for Word, PowerPoint, Excel, Photoshop, the list goes on. I would go so far as to say that any company or school currently subscribed to Microsoft Office should switch over to this simpler, cheaper alternative. Your productivity will skyrocket. Of course, all this is good. I'm even using it to create this presentation right now. But that isn't what the title said the video was about. When the creators of ScratchJr set out to make a programming language illiterate children can use, that required a few features being dropped. Nothing too major, just functions, while loops, strings, conditionals, and variables. In an ironic twist, for even ridiculously simple programs, ScratchJr is ridiculously difficult to use. And that raises the question of this video. How far can we push ScratchJr? First off, what does ScratchJr give us to work with? The short answer, not much. You have your basic movement options, the ability to hide, show, shrink, grow, and you can say stuff. Now, other than that, there is a simple repeat command, but it can be replaced by repeating lines of code, so don't worry too much about it. There are also a few triggers, namely the on flag, on touch, on click, on message, and message blocks. These execute the code that follows them when the event in question occurs. The key to writing actual programs in ScratchJr, and what got me started down this dark path to begin with, is the realization that the on-touch blocks can act as conditionals. A sprite could send out one message if it collided with another sprite, whereas it could send out another message if a period of time passed with no collisions. With this realization, I started brainstorming. How can one emulate a Turing machine in ScratchJr? For those who don't know, or just need a refresher, a Turing machine is an abstract machine that changes values on a strip of tape and can follow instructions. Despite sounding quite simple, a Turing machine is the most common standard for what a programming language is, and can in theory compute anything a modern-day computer can. If ScratchJr can emulate a Turing machine, it can do anything a normal programming language can. My first theoretical models involved a long string of variables that could be adjusted by a moving pointer, all controlled by a moving tape of sprites. This was far too complicated to actually implement, so I found a much better solution. In 1961, two mathematicians, Marvin Minsky and
Zdzisław Melzak,
invented a two-instruction language for programming an infinite abacus, which is exactly what it sounds like. The first instruction is to increment a specific cell, and the second instruction is to decrement a specific cell if it is greater than 0. Otherwise, jump to a different instruction. This is much easier to program in ScratchJr. I started by again thinking about having a cursor that moves back and forth to modify the individual variables. But then, it hit me. We have message blocks that can already transfer control between different sprites. We just need to tell the sprites to move down or move up. If our control sprite receives a collision, this means that one of the variables decreased and that it went below 0. We can then just tell that variable to reset its position, and we can route our program to a different message block. This leaves us with an incredibly simple program with one control sprite, as many variable sprites as we need, and a few buttons, all in the shape of blocks. To create a simple program this way could be possible by hand, but if we want to get any more complex, we're going to need code to do it for us. I wrote this in Python 3, sorry if that offends you. It really isn't that processing intensive, so there really wasn't a reason to write in a faster language. I split the code up into a few parts, but the only sections that are actually important are highlighted right now. Since the actual ScratchJr files are JSON in a local SQL database, and I don't want to deal with that, I wrote a wrapper library that pretty much covers up all the conversions to the final JSON form of the project. The project class is pretty much a container for pages, and the page class the same, but for sprites. Sprites can have coordinates, a texture, and a size. In addition, they can also take custom parameters, which just get tacked onto the final JSON object. The most important part of the sprites, of course, is that they can run scripts. In this wrapper, a script is just a list of script elements, which can be easily created by using the name and parameters that the script element would have in ScratchJr. The wrapper includes an example project, which takes the name of the project you would like to edit, the name of the sprite you would like to create, what it should say, and how many times it should say it. After it gets this information, it prints out the final JSON code and sends it to ScratchJr. As you can see, the demo works exactly as intended. Now second, we have the actual compiler for my Infinite Abacus code. Without going too in-depth, my version of the Infinite Abacus is quite extended, so I will just quickly go over the syntax. As you can see in this demo file, you can increment certain cells by any arbitrary integer amount, conditionally decrement cells, add a goto to the end of the line, reset cells, print predefined text, and get input. Execution of code halts when the file ends. This is parsed through a bunch of match case statements, which then create sprites and give them scripts so that they properly execute the code. The best part about this? It actually works. Here I'm compiling a small program, and here it is in ScratchJr. All I do is enter the number of times I want for it to say hello world, and it says it exactly that many times. I have another program here. This one lists off all the square numbers in order. Because ScratchJr has a cap on how fast sprites can move, this and the other programs in this video will be sped up for your viewing convenience. Now, I know these things may seem simple, but you still haven't seen their code yet. Here's a quick color-coded version of the code for the squares.ia program, IA standing for infinite abacus. The beginning initializes our first square to 0 and our first odd number to 1. If you're wondering why we are keeping track of odd numbers, all square numbers are part of the arithmetic series of odd numbers, so repeatedly adding odd numbers together will give square numbers without actually having to square numbers. Next, we add the odd number we have to the running square number. This number is stored as 3 separate digits and makes use of rollover checks to carry a 1 for the addition. We then head to this section of code, which basically acts as a function call. It sets the register variable to 0 to signify where the function was called in the code, and then sets the input to the function to the first digit of the square number. After sending control of the code over to the print code, which simply prints out the digit, it returns control back to the location indicated by the register variable. This new location is also a function call, but for the second digit. So after it prints the second digit, we end up here, and we print the third digit. Finally, after we've printed all the digits, we go up here and add 2 to our odd number to get our next odd number, and start the whole process over again. If you want a bit more information, here's a very detailed flowchart that you can pause on, and here are the variable names to go with it. No variables, no if statements, no for loops, no math. It shows how far people can go if we put our minds to work. Truly, this was one of the stupidest things I have decided to go ahead with doing. I mean, what's the benefit? It's useless except for a cool YouTube video, and it took me 3 months to make. However, you know what the complete opposite of making this is? Pressing the subscribe button. It takes almost no time and really does make an impact. Thanks for watching all the way through, especially on this longer video. Let me know what you think about it. Thank you for the continued support. The Discord is linked below along with the code.